Hey, what's up guys? My name is Cherno and welcome to episode 101 of Game Programming. Freaking happy new year guys, it's the 2nd of January right now. I was actually going to make a video last year, or 31st of, from the very last day of last year, but unfortunately half of it didn't freaking record, so that's annoying. But anyway, we're going to hop into this. This year's going to be freaking awesome, I promise you guys. And today we're going to be, I guess, continuing our kind of A-star search algorithm. If I open that real quick, you guys will be able to see that we did in fact finish it. Here it is. This find path method in the level class. Right, what this does, of course, I'll quickly go through this in case you guys have forgotten or something. Essentially, I guess we enter a start coordinate, another coordinate, which is where we want to go. And then what this method does is it calculates a path to that from the start to the goal, right? And what it returns here is a list of nodes. So what it means is it actually traces the path once it figures it out, and returns it as an array list of nodes. Now, nodes are a bit better than vectors because nodes also contain the parents and other information. But the main thing that we're going to use from node, of course, is this this tile vector 2i, okay? Because that's essentially the next step of where we want to go. Right? Now, if no path, and then it obviously returns the path. If no path is found, it returns null, okay? So what we will do to test this out, because if we run this right now, what we've kind of got going on is this guy here moves. We've got different kinds of mobs. We've got this guy, these mobs who just move around randomly. We've got this king this red guy who kind of just follows us for a bit, but then stops, and obviously he can't go through walls or anything. So if we were to trick him like that, he's not going to be able to, as you can see, he's not going to be able to pass that wall and get to us because he's stupid. Now let's, I guess, to demonstrate this, I'm just going to make a new mob, right? So right click, new class, we'll call it star because it's the A-star search algorithm, hilarious. Hit finish, and this mob is going to basically be the same as our chaser, right? In fact, I'm just going to pretty much go Control A. I'm just going to grab all this, copy it, and paste it into star, okay? And make sure we, of course, extend mob. All right, and of course I'm gonna have to change a few things like this this constructor here, but the sprite's gonna be the same. Sorry, not mob, star. The sprites are gonna be the same. The move method and the update are largely gonna be the same, and the render, of course, is going to be the same. One thing I do want to do though, just to kind of randomize, I guess, what it looks like, is if we control click on render mob to go to render mob, I'm just gonna pick out a nice color, like a nice kind of yellow color, probably this color right here. So okay, so what we're going to do is we're going to say if mob is an instance of star, right, and the color is that little purple default color. Let's import star, by the way. We'll change it to this color right here. All right, and that color, in case you guys were wondering, that color is this one right here. So go to colorpicker.com, paste that in. It's kind of like a yellow gold kind of desaturated kind of darkish yellow color, okay? So what that's going to do is largely just allow us to tell the difference between all the other different mobs that we've made. So if we go into our spawn level class, because that's the class that actually spawns these things, let's go ahead and add a new, we'll add a new started level, and we'll put it at coordinate 1735, so probably just a bit higher up than that one, because I remember that one's like in the middle, and then we'll move it a bit to the left so that it's kind of not, because there's that kind of like pillar thing in the way. We don't want that to be in the way. I don't know. These coordinates might end us up inside a wall, but we'll see. All right, great. So the other thing we want to do is let's see. Let's close a few of these things. So we don't need node, we don't need chaser or screen or spawn level anymore. Right, okay, so first of all, let's get rid of, so I guess the AI, because we just copied and pasted this from Chaser, didn't we? The difference, I guess, or the AI of that Chaser was essentially just this, right? Just this. So if we delete that, our mobs aren't going to move, right? So let's just run the game to see if we get that star, and there he is. That's actually perfect. Look at that, right in the middle. Brilliant. So this is the mob, right, that we're going to actually make, I guess, the A-star work on, okay? So this star mob, and that's actually very fitting that he's all yellow and stuff, but this star mob, right, we're actually going to give him the A-star search algorithm so that he can find and follow the player. So what should happen, right, once we complete this, is if we get our player all the way over here, he should be able to find a way around this wall and essentially just, I guess, move to our position, okay? So that's the goal for this episode. And we're gonna start doing that right now. Okay, so first thing we need to do is actually, I guess, call this this method, right? We've got this find path method, which is what's gonna actually find the path using the A* search algorithm here. We of course have access to the level class because every single entity needs to be initialized when it gets added, and this init method here sets the level to the current level, okay? It's pretty simple and very common framework. So in other words, if you want an entity to be inside a level, you have to, the level actually adds that entity and then references this as the level that it's contained within. So in other words, an entity can't just exist, it has to be contained inside a level, and that level has to spawn it. Which makes sense when you think about it, right? Very simple. All right, that's a lot of varies right there because I'm freaking excited. Okay, so first video of the year, let's do this. So I'm gonna try and do this without any errors. So px, that's gonna be our player's location. So the way we can get that is level.getPlayer at index 0 dot get x. All right. So what that's gonna do is get the x coordinate of the player. Now, very important that you guys realize this. This is going to be in pixel precision. That's a huge difference, right? There's tile precision and then there's pixel precision. Tile precision is the actual, I guess, well, tile precision is the easy one, right? That's just the coordinate of a particular tile on a map. So like 17, 35, which is exactly what we did to our star here. We added them at 17 by 35. Pixel precision is also very important. Pixel precision is like the absolute pixel kind of location of where he is in the level, right? Because our entities can't just move from tile to tile, that would be boring. That would be kind of like a, yeah, if we could just move, like, we can't move in between tiles, so we just hop over to the next tile, then to the next tile, that kind of stuff. That's very different. We don't do that, right? We get to move smoothly in between tiles, right? We don't just hop to the next tile. So because of that, we have pixel precision. Now, this, of course, the getX, of course, of the location of the player, since we can move in between tiles, is going to be in pixel precision, right? So in other words, it's going to be something like 260 rather than something like, 17. All right? It's going to be like something like 260 instead of 17, okay? And that can be an issue, okay? Because obviously you might have noticed that when we run this find path algorithm, what happens here is we assume, you can see that we get the tile out, we get tile, we just get x plus xi. So in other words, these two vectors have to be in tile precision, not in pixel precision, because we're finding the path between one tile and another tile, okay? So that's something that's really important, okay? Because I imagine a lot of bugs would come there. And I have actually made that mistake before. So let's also get the y coordinate here. All right, so let's make a vector out of it as well, since we need to fit in vectors into our parameters here. The other thing that's really important is that, well, let's actually, okay. So let's, in other words, what I've just mentioned, right? I've talked about tile precision and pixel precision. The reason I've talked about that stuff is because now that we have px and pixel precision, to convert it back into tile precision, right? We simply need to kind of, well, divide it by 16, right? Because the tile is 16 by 16 pixels. 16 pixels wide and 16 pixels high. And because the tile is that size, we know that if we want to convert from pixel to tile precision, we divide it by 16. If we want to convert from tile to pixel precision, we multiply it by 16. Okay? Very simple stuff. So, now that we've done that, now that we've gone over that, the start is not going to be the player's position. That's going to be the goal, right? The start's going to be our current location, or I guess the location of this current star. We can use the getX and getY methods to get that location. So we'll go getX, getY. But wait, let's import that. But wait, okay, that, remember, is in pixel precision as well. But the vector that we make needs to be in tile precision. So to do that, we're going to pretty much divide by 16. Except I'm not going to write it like that. I'm actually going to write it like this, okay? Divided by 16, okay? And of course this, oh, sorry. Big mistake there. So instead of divided by 16, I'm going to go shift right by 4. And that's the same, right? Because 2 to the power of 4 is 16. And a shift right indicates a division, essentially. we'll do the same thing with this. Okay, it's just going to be a bit faster since we'll be running this very often. Now, the other thing is the destination. And the destination is going to be the px that we just made, again shifted right 4, and the py shifted right 4, okay? So this is going to divide them both by 16. Pretty simple stuff. A lot of people say, why don't you just write divided by 16 for readability? Honestly, this is as readable to me. If not, if you guys don't know your powers of 2 like the back of your hand, then, well, you should get on that. Now, this is where it's kind of gonna get awesome. We want to now, I guess, keep a list of those nodes, right? Because level returns, this find path method returns a list of nodes. And we want to be able to access those nodes. So we want to make an array list of nodes here and set it equal to that find path method. Now, we don't want to do that every single frame, okay? We could, but what happens is if we start doing that kind of thing every single update, because the move method is of course in update, and if we call it every single update, it's just going to be a bit, it's going to get a bit slow, okay? This A-star search algorithm is really efficient, but it is still, as you can see, quite a lot for your processor to process, right? And it's all right if we've got one entity, but we've got one kind of star object. But what if we've got like this star entity? What if we've got like 1,000 of them in a level, and they're all accessing the A-star search algorithm 60 times per second? You know what that means, right? That's 60,000 A-star search algorithm processes in 1 second. That's a lot, okay? We don't want to do that. That's just going to slow it down, especially on slower computers. So what we want to do is create a global variable here. Not really a global variable. It's called a field, actually. We want to create a field here, which is going to be an array list of nodes, and we're going to set this equal to path. All right? And what we're going to do, right, by default, and let's just import our node here, we'll set it equal to null by default, okay? And what we'll do is, for now, right, we just want to go ahead and say path equals level.findPath, and then the start and goal, okay? And the goal is the destination. All right? Now, just for now, I'm not gonna make it not run every single update, just so I can demonstrate it, but we'll fix that in a minute, okay? So, we've just admitted here that path can sometimes be null, and especially it will be null sometimes, because occasionally you might close a door behind yourself in this game, and there might not be a way anymore for an entity to get to you, or for any way. There just might not be a path between two locations on the map, right? Because of whatever circumstance. So occasionally path is null. So what we want to do is we want to first of all check if path is null, because if path is null, we can't use it. So if path does not equal null, we're going to do whatever's here. Otherwise, we'll just not move at all, because XA and YA, as you can see, will be 0, so we're not going to move anywhere, okay? You could also do your else here and then be like, all right, well, if there is no path to the player, let's just move randomly, or whatever other AI you kind of want to script in here. But for now, we're just going to leave it at that. So in other words, if there is no path, our entity is not going to move. At the moment, there should always be a path, so that's all right. So if path, if path.size is greater than 0, okay, and this is where it's going to get interesting. We're going to actually create a vector here called, I'll just call it vec, equals path.get path.size minus 1 dot tile, because tile is the vector from that. Oops, tile, can't type today. All right, you guys might be all confused. What's going on here? So let's open paint.net and get down to this explanation stuff. Right, so what we've got going on right now is, let's grab a nice little orange color. This is the star entity, this is the player up here, and we want to get to the player, okay? So what happens is we run the A-star search algorithm. It gives us a bunch of nodes of how to get to the player, right? And then what we have to do is kind of follow those nodes. Now, it's very important, if you go back to level, you'll actually be able to see that in other words, if we do find our goal, right? In other words, if the A-star search algorithm actually finds the goal, which it will, or it should anyway, in this current map, if it does find the goal, what it's going to do is it's going to go through every single node here that it used to get there, right? It's going to make a new array list here, and it's just going to trace back the parent, okay? So in other words, while current.parent equals null, because it doesn't equal null, because if current parent is null, it means it's the very first node, right? Because you can see the first node we create here has a parent of null. In other words, if the current node is not the first node, then keep tracing back our steps. Let's add the current one and set current equal to current.parent. So what it does is the A star search algorithm, this is it. It finds the path to the end, and when it does, it's going to start adding number 1, number 2, number 3, number 4, number 5, number 6, number 7, whatever, okay? It's going to add those in this order to the array list here, okay? And then return it. Now, that's important because it doesn't do it in the other order. So that means that the first node in there is the one closest to the destination, not closest to the origin, the start, okay? We have to account for that. So instead of having to go this way, we actually have to go, okay, move to node 7 first, then 6, then 5, then 4, then 3, then 2, then 1, then there, okay? Like that, not the other way around. And because of that, we can't simply go path.get 0, because that would be the one closest to the destination. We go the opposite pretty much, path.size minus 1. Path.size is, of course, the amount of nodes in this path array list, and we use minus 1 here because, of course, it starts at 0, not 1. So if we call this, it's just going to crash with a list index out of bounds kind of thing. All right, great. So let's kind of do our AI here. Very, very simple stuff. If x, being our current x, is less than vector.getX, then we want to make sure that you actually multiply this now by 16. Right, do that. Because this vector is going to be in tile precision, but our x coordinate, of course, is in pixel precision. So if that is the case, then let's move it by, well, it's just plus plus, okay? xa plus plus. So in other words, if our current location is too small as far as the x goes, in other words, if the x that we're supposed to move to is to the right of our current x, then increase xa in order to move to the right, okay? Simple stuff. We actually covered this for our chaser, right? We had this system here. We're going to do the same thing here, except instead of going to the player now, it's going to go to that vector coordinate. This is very simple code that will just allow you to, to move from one location of the map to the other, okay? From one point to another. Change this to YA, of course, and Y greater than Y. All right? So what this is going to do is, of course, just simply move our current star towards this vector here, okay? Simple stuff. And that's it, okay? That's actually it. That's going to work. Now, I talked about efficiency. Let's talk about that now. Let's make an integer called time, set it equal to 0. Every update will increment time. And what we'll say is we'll only update the path if time is, let's just say once per second, right? So if time mod 60 equals 0. So once per second, we'll update this. Now that's going to be a bit too slow, you'll find, because it doesn't take us a second to move to the next node. But that's just going to be a good kind of representation of what's going on. Okay, so you guys might be like, all right, well, if you always get path.size minus 1, if you always get this, how is it going to go past the last node? Well, the thing is, since we recalculate a path, which is important and inevitable, by the way, we could have easily just gone ahead and say, you know what, calculate the path once, and then just go first to this one, then 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 this one, okay? We didn't have to recalculate the path, but if we do that, the player obviously has the capability to move. So the player might have moved over here by now, but, this guy is just getting here now, okay? So our orange kind of blob is just getting here, but the player's already moved. So there's no point, okay? Unless you want the mob to behave that way, and we might cover that in the future if it's requested, or if I think that it will fit into the game nicely as an enemy type or something that always just, I guess, goes to your last location first and then follows your steps. But in this case, we kind of want the mob to move to the player's current location. So if the player moves this way, our mob is no longer going this way, it's actually going this way now, okay? That's what we're gonna do, at least for now. So in order to do that, how this works is because it's recalculating the path, it knows that it takes in the current location of this guy again. So if we moved up to node 6, right, we're already here, right? And then it recalculates the path here, and then it gets the closest node to us, which is now this node, okay? Because we're already here, we're not here anymore, we're here, okay? And it moves over to this node, and then it keeps going until it reaches the destination. So in other words, it's always getting the closest node to itself. So let's run this and see what happens. Alright, so you can see the slow thing, right? This guy's only moving once per second pretty much. But you can see he's coming to us, alright? So it's working in a way, yeah? He's coming to us. Now let's see if we can get around walls, right? Let's kind of move up here. And I don't think the mob collision is perfect either, so just be wary. If he can't go across walls or something, that's my bad. Okay, so let's go over here. Let's see if he can make it across this corner. Okay, sweet, check that out. So you can see he's actually walking across this. And he gets stuck here, and that's just because of my collision code, because we changed around a lot of the collision, and we didn't update it for mobs yet. So that's the reason for that. But you can see he's coming at us. Let's go across the wall here, and you can see he actually moves up. Look at that. He's moving up. There he is. He's coming towards us, and he's probably going to get stuck here. Yep. Let's make him go this way. There he is. See? So that's awesome, right? He has the capability here to move across walls. Let's go over here, see if he comes to us. No, let's just stop this crap. Let's make this mod like 3, so 20 times a second. That should make him move, as you can see, a lot faster here. And he's going to get stuck, unfortunately. I'm going to probably fix collisions for next episode or something, but let's see if he can find us here. He's probably going to get stuck somewhere. No, there he is. See? Check that out. And he found us. So now our guy can walk through walls. Now there are a few quirks apart from the collision, which is horrible. Probably should fix collision first. But there are a few quirks, and that is he sometimes changes directions randomly. But that's alright. That's probably just, we can iron out those aesthetical features a bit later. But the main thing is that the algorithm is working properly, and you can see it is. Alright? So that's awesome. Anyway, that's probably going to close off this episode. Hope you guys enjoyed it. Thanks for watching. And next time we're probably going to fix this collision stuff because it's bugging me. It's not really working properly at all, as you can see, and it's getting annoying. Anyway, that is the A-star search algorithm working now. Hope you guys enjoyed. If you did, please hit the like button. I appreciate that, and I'll see you guys in the next episode. Goodbye.